So let's just start with example 13. How we're gonna prove that this side equal to the other side. This side equal to the left side. So first thing I'm gonna write down cosine x. You can keep it in parentheses, it's fine. And here is secant x minus cosine. Because this one is an angle for the secant, this one is an angle for the cosine. Now, the second step, what are we gonna do? If we distribute the cosine on secant and cosine, so it's going to be cosine x times secant x minus, I'm distributing the cosine. Cosine times cosine is going to be cosine squared x. Now next step, this one is going to be equal cosine x. I know that secant to the x equal 1 over cosine x. Secant is the reciprocal of the cosine, so here is going to be 1 over cosine x minus cosine squared to the x. Now cancel this one with this one. What's the left? 1 minus cosine squared to the x, which is equal to sine squared to the x. None from this one. Example 15. Now let's go to example 14 and check what we're gonna do with example 14. We do exactly the same thing, but always you have to look what's the first key I have to use to solve this problem. So secant to the power 4 to the x minus tangent to the power 4 to the x. The first thing, if you look to this side, is to like x to the power 4 minus y to the power 4. If I assume that the secant is x and the tangent is y, it's difference between two squares. So, and to solve this one, you're gonna say x, open two parentheses, here is x to the power 2 or 2 here, and y to the power 2, y to the power 2, 1 plus 1 minus. Talking about this problem. Now I need to do the same thing, but I have secant to the power 4x minus tangent to the power 4 to the x. So in this case, I'm gonna open two parentheses. I'm gonna say this is equal. There's two parentheses. I'm gonna say on the first one, here is secant squared to the x. And here is secant squared to the x. And here is tangent to the power 4 to the x. And here is tangent to the power 4 to the x. 1 plus, 1 minus. Now what do you think? What's the next step? So one of the identities rule, it says every time when you have 1 plus tangent squared to the x equal secant squared to the x. So now if I move the tangent to the other side, so 1 is going to be equal tangent squared to the x minus secant, the opposite, because we're gonna move the tangent. So it's going to be secant squared to the x minus tangent squared to the x. That's mean secant minus tangent squared is going to be equal 1. So if I look here, secant squared minus tangent, this is squared, not to the power 4. So this one is squared. And this one is also squared. Which means factor and the difference between two squares. Now, secant squared minus tangent squared, the whole thing here equal 1. So the result for this problem, just gonna say it's secant squared to the x plus tangent squared to the x. That's it. You don't have to write down this parentheses. That's it. So let's go to the next problem. Check how we're gonna solve this problem. Number 15. Number 15. Let's see. We have 1 minus sine squared to the x over cosecant squared to the x minus 1. So I'm gonna take the left side and I need to get the right side. So 1 minus sine squared to the x and everything divided by cosecant squared to the x minus 1. That's one of them. Let's check here, step by step. I already know if I have sine squared to the x plus cosine squared to the x 1. If I keep the sine or keep the cosine, move the sine to the other side, that's mean cosine squared to the x, cosine squared to the x equal 1 minus, move the sine to the other side, sine squared to the x. That's what I'm going to use on this problem. So 1 minus sine squared to the x, this one is going to be cosine squared to the x. Now the same thing with the next part, cosecant squared minus 1. I already know cosecant squared minus 1 equal cotangent. Cotangent to the x equal cosecant squared to the x minus 1. So I'm going to plug it instead of this one, cosecant squared minus 1 equal cotangent. Cotangent squared to the x. Now we need to think how we're going to simplify this one. Here's another identity. We know that cotangent squared to the x equal, because the cotangent by itself equal cosine over sine. Square, so cosine squared to the x over sine squared to the x. So I'm gonna plug in instead of cotangent, let's see, this is equal cosine squared to the x divided by cotangent, so cosine squared to the x divided by sine squared to the x. Next step, I can write down cosine squared to the x of x divided by 1. In this case, this is division. So I'm going to write down the division, which is the top part, cosine squared to the x over 1, and take the reciprocal, take the multiplication, change the division to multiplication, take the reciprocal for the second part, which is going to be sine squared to the x divided by cosine squared to the x. Cancel the cosine with the cosine, so the left is going to be sine squared to the x, which is right. That's it. What was the problem? Let's go to the next problem. Next problem is going to be use the fundamental identities to simplify the expression. So we need to simplify. First of all, we need to simplify the whole expression here. So I'm going to write down cosine squared to the y over 1 minus sine to the y. I already know I can't do anything here, because first of all, there's no square, so I have the square here. I already know cosine square to any number, let's say to the x, equal 1 minus sine squared to the x. Now, if I have cosine squared to the y, it's going to be 1 minus sine squared to the y. I then put parentheses, because I'm going to put parentheses here. And everything divided by 1 minus sine to the y. Let's think. I have minus between two squares. Y Because one, I can say it's 1 times 1. And sine square is sine y times sine y. So in this case, I'm going to say this is going to be equal. We'll open two parentheses. One here and the other one here. Sine y here and sine y on the other side. 1 minus 1 plus, and it doesn't matter which sign is going to be here or here. You can put a plus here or minus here. Over 1 minus sine y. So now we're going to cancel this one, put the whole thing here. So the result is going to be 1 plus sine y. So here's the solution for problem 16. Let's go to the next problem. Number 17. Let's check how we can solve this problem. Perform the multiplication. So the average is only do multiplication and use fundamental identities. I have two binomials, so I'm gonna FOIL it. The first thing, 3 cosine x times 3 cosine x is going to be 9 cosecant, 3 cosecant times 3 cosecant is going to be 9 cosecant squared x. 3 cosecant x times 3 is going to be minus 9 cosecant x. Now 3 times 3 cosecant x will be plus 9 cosecant x. 3 times 3 times 3 will be minus 9. Now if you look here, I can combine that terms. This one with this one is going to be 0. The left is 9 cosecant squared x minus 9. Then can I simplify more? Yes, because I have 9 times cosecant minus 9. So I can factor out 9, and the left is cosecant squared x minus 1. Now, if you look, cosecant squared x minus 1 is going to be cotangent. That's mean this one is going to be 9 cotangent squared to the x. That's it. What's the problem? Let's go to the next problem. Let's check how we're gonna work with this problem. Do step by step. First of all, look what we have here. We have cosine x 1 plus sine x minus cosine x 1 minus cosine x. We have different denominator. Keep in your mind, this one is still a fraction, plus or minus a fraction. And every time when we have different fraction, for example, if we have 3 over 4 plus 5 over 3, different denominators here, we need to find the common denominators. We're going to do the same thing here. In this case, to find the common denominator, I'm going to multiply by here on this side cosine x over 1 plus sine x. To find the common denominator, here is the minus, and we have cosine x over 1 minus sine x. So the common denominator here, I have to multiply this side by 1 minus sine x. And multiply this one by 1 minus sine x. So multiply by 1 minus sine x, and multiply by 1 minus sine x. Then we're going to do the same thing with the other side. With the other side, I'm going to multiply by 1 plus sine x, 1 plus sine x. Let's see what we do. be careful when you do multiplication. You have to FOIL it here. So on the top, what are we gonna get? This one's going to be equal. Cosine x times 1 is going to be cosine x minus cosine x times negative sine, so it's going to be negative cosine x sine x. And everything here divide by. We're going to FOIL these. This looks like we have FOIL in 2 parentheses. So 1 times 1 is going to be 1, 1 times negative sine, so minus sine x. Sine times 1 and plus sine x. Sine times negative sine, going to be negative sine squared of x. This is the whole thing here only for this part. Minus. We're doing the same thing with the second part. But there is minus here. So keep in your mind, you have to open parentheses because then the minus is going to be distributed on the result. You don't need any confusion. So cosine, I'm going to distribute everything here. I kept the negative side out. So cosine x times 1 is going to be cosine x. And cosine x times sine, you FOIL. But now you distribute because we have only 1 term and 2 terms here. Cosine times sine will be plus cosine x sine x. Those are the parentheses here. And everything divided by. I'm going to FOIL these 2 binomials. 1 times 1, so it will be 1. 1 times sine, so this sine x. Negative sine times 1 minus sine x. And negative sine times sine minus sine squared of x. Now, next step, I can simplify this part, which is cancel this one with this one. Same thing on this side, we're gonna cancel this one with this one. 1 plus 1 minus. The left here on the top, which is cosine x minus cosine x sine x divide by. After I do the cancellation here, I have 1 minus sine squared to the x. I already know 1 minus sine squared to the x is equal to cosine squared to the x. Minus. Do the same thing here. After I do the cancellation here, I have 1 minus. Don't confuse yourself about this plus. This is plus with the sign, and you already canceled with the negative sign. So 1 minus sine also is going to be cosine squared to the x. Now, next step, still have parentheses here, distribute the negative sign, so I'm going to keep the parentheses here, so not to get confused. So minus times, we'll keep this one like cosine x plus cosine x sine x. Let's check the next step. I have the same denominator here, and that's why I multiply by here by 1 minus sine and here by 1 plus sine to get the common denominator. So now next step, I'm just going to say it's cosine x minus cosine x sine x, everything divide by, because it's the same denominator, so I'm just gonna add here's cosine x. Cosine squared to the x. Distribute the negative sign, negative times cosine, so it'll be minus cosine x, and negative times positive minus cosine x sine x. Smoothly. Now let's look. Do you have cancellation? Yes, I have plus cosine and minus cosine. So cancel this one with this one. And what's the left? The left is negative cosine sine and negative cosine sine. That means the left is negative 2 cosine x sine x, and everything divided by. Cosine squared. Cosine squared, it's cosine x times cosine x. Cancel these two cosine. So the result is going to be -2. Sine over cosine is tangent. That's going to be that's it for the system. Let's jump to the next problem. Number 19. Number 19. You do exactly the same thing. Don't confuse yourself about this side. Always they tell you when they ask you prove that, that's mean we need to prove this side equal to the other side. So I'm gonna write down cosine x over 1 plus sine x plus 1 minus sine x over cosine x. I need to prove this side equal to secant x. And again, this one, there's no square here, there's no square, there's no square, there's no square, and it's a plus. Plus between two fractions. If it's a plus between two fractions, what we going to do? We're going to find the common denominator because it's a plus between two fractions. So go ahead and find the common denominator. Now we think, how are we gonna find the common denominator? That's mean I have to multiply here, and I have to multiply here. So let's do the same thing. Find the common denominator, must mean I have to multiply this one by cosine, multiply this side by 1 plus sine. This one is a plus. Okay. So I'm gonna say this is cosine to the x over 1 plus sine to the x. I'm going to multiply this one by cosine x and this one by cosine to the x. Here's the plus sign. Do the same thing with the other side. 1 plus sine x over cosine x. I'm going to multiply by cosine by multiplying by 1, this one times 1 plus sine x. This side by 1 plus sine x. To get that common denominator. So on this part here, cosine times cosine is going to be cosine squared to the x over. I don't have to distribute because this binomial here, just write it down as cosine x and 1 plus sine x. You can keep it like this. The same thing with the other side. Here's a plus. On the top, I have to FOIL it. 1 times 1 is going to be 1. 1 times sine plus sine x. Sine times 1 plus another sine x plus sine squared x. And everything is divided by, keep exactly the same thing. Cosine to the x, 1 plus sine to the x. Now I have the same denominator, and that's my goal. So I can combine everything here. So this one is going to be equal cosine squared to the x plus 1 plus sine plus sine plus 2 sine to the x plus sine squared to the x. I combine sine and plus sine, so it will be 2 sine. Everything is divided by cosine x, one plus sine x. Next step. How are we gonna simplify this? I already know there is one of identities. It says cosine squared to the x. If you add it to the sine squared to the x, it should be equal to 1. So if you look here, this one plus this one is going to be equal to 1. So if I combine cosine plus sine, it's going to be equal to 1. And 1 plus 1 is going to be 2. That's mean by adding this one plus this one is going to be 1. 1 plus 1 is going to be 2 plus 2 sine to the x, and everything is divided by cosine x, 1 plus sine to the x. Next step. If I factor out the 2 from the top, factor out the 2, the left is 1 plus sine x divided by cosine x, 1 plus sine x. Now cancel this one with this one, because there's multiplication here, so I can cancel it. The left is 2 over cosine x. And then I can say it's 2 times 1 over cosine x. 1 over cosine x is the secant. So it's going to be 2 secant x. And that's going to be the answer. That's it. What's the problem?